Hello everyone. My name is Abhishek and I am mathematics faculty here in Ask IITians. And this is the lecture number 1 of the chapter Direct and Indirect Proportion. And before we actually jump into the chapter or to the theoretical portion of this particular chapter, it's very important to know the weightage of this particular chapter, both for your school examination as well as your Olympiad examination. So, if I talk about school examination, then you can expect questions carrying around 8 marks from this particular chapter. So, broadly speaking, you can say around 2 to 3 questions can be expected from this particular chapter. On the other hand, if I talk about Olympiad, then in Olympiad, around 2 questions can be expected, and 2 to 3, I would say, the questions can be expected from this particular chapter. And this particular chapter is very, very interesting as well as easy chapter also. It's just that you should be able to extract the information provided in the problem. You should be able to put that in order. And after that, it's just the application of the formula which is going to work. If you applied that formula properly, you will easily get the answer to that problem without any hesitation. So I hope the weightage of this particular chapter is clear. But if I talk about school exams, then you can expect questions of around 8 marks. If I talk about Olympiad examination, you can expect around 2 to 3 questions from this particular chapter. Okay, let's move ahead. So which topics are we going to cover in this session, guys? In this session, we are going to cover 3 topics mainly. First is what is the meaning of variation? Okay, variation, this is important because variation will further be divided into 2 subtopics, which is the name of the chapter itself, that is direct variation and indirect variation. So we will have we will study about 2 sub topics of variation, that is indirect and direct variation, okay, or direct proportion. The second topic we are going to cover is direct proportion, and the third is we are going to discuss few problems based on direct proportion as well. So let us understand what is the meaning of direct proportion. I hope you can see these 2 giraffes here. Okay, so the height of this giraffe, let's say I am going to denote the height of this giraffe by h1, and I am going to denote the height of the second giraffe by h2. Then it is very clear here that h2 is greater than h1, right or not? H2 is greater than h1, right? So can we say in this situation that the height of the giraffe depends upon the ears or the age of the giraffe? Can we say that or not? Right? The height of the giraffe increases with the age. We can say that, right? The height of this first giraffe, which is in front of you, is lesser than the height of this second giraffe. That indicates that the age of this first giraffe is very less as compared to the age of second giraffe. So here in this case number 1, what is happening? We can say that height of giraffe that you have, okay, that is directly proportional, to age of giraffe. Okay, that means if the age of giraffe is more, the height will be more. If the age is less, the height will be less. If I talk about this second situation, guys, okay, this is related to football. Then the scoreboard, the score that a team is going to have on the scoreboard, will that be directly proportional to the number of goals scored in a match or not? Means if you are scoring more and more goals, or your number of goals scored is more, then eventually your eventually what is going to happen, eventually your scoreboard will be much better, or you will see more goals scored over on your scoreboard, right or not? So here I can say more score, that is directly proportional, to the number of goals scored, right? Number of goals scored. So that means you score more goals, their score is going to be much better. So if you look at both the situation, guys, what are we observing? We observe that when one of the quantity is changing, then the other quantity is also getting affected. And it is not necessary that the other quantity will always increase. Let's say one of the value is changing, then it is not necessary that other value will also change. there is a possibility that on increasing one of the value, your second value might be decreasing, and vice versa. Means we have two sub cases. One of the cases, when one value is increasing, the other is also increasing. When one is decreasing, the other is also decreasing. When you have this situation, then that situation is referred to as direct proportion. Okay, we will study about it in the next slide. On the other hand, if we have a case in which when one of the value is increasing, the other one is decreasing, or when one of the value is decreasing, the other one is increasing, means opposite is happening here, then this situation is referred to as indirect proportion or inverse proportion. Is that clear? So there are multiple examples that you can see in your life of this particular topic, that is variation, right? Let me show you one of the example in the next slide as well. I hope you all can see this train moving very fast. Okay. So let's say I will take an example here. Let's say I have to move from place A. Okay. Place A. This is place A, let's say. All right. And I have to move to this place B from place A. Correct. So place A and place B. And let us say the distance between these two places is D. Okay. Distance of these two places is D, right? On the other hand, let us assume that the speed of this train that you can see, that is VA. Speed of train is V. All right. Now, speed of train is V. See, the distance between place A and place B, that is going to remain constant, correct or not? The distance will not change. For example, if I talk about distance from here or to some other place in my locality, that distance is going to remain fixed if I follow a certain route. Okay. So here the distance which we are talking about, D, that is going to remain fixed, right? Now we know the relation between the speed is equal to speed, distance and time. That speed is always given by what? That is always given by distance by time, correct or not? This is what how we give it. Now because your distance is fixed, so if I increase the speed of a train, right? Let's say this train is traveling this distance between place A and B in 2 hours, okay, at a normal speed, or you can say, let's say at a speed of V1, it is traveling the distance between A and B in 2 hours. Okay. If I increase the speed of this train, as the distance is fixed, the speed has been increased. So the time taken to cover the same distance, will it decrease or not? Right? I'm repeating again. Your distance between the two places under consideration, that is place A and place B, is fixed. Okay. The second thing is speed we are increasing, right? We are increasing speed. So if we are increasing speed, then the time taken to cover the same distance, that will decrease, correct? On the other hand, if I decrease speed, the time taken to cover that same distance is going to get increased because your speed has been decreased. So this situation that I discussed just now, where on increasing speed, time taken to cover the distance between A and B is decreasing, and on decreasing speed, the time taken to cover the same distance between A and B is increasing. This is the case of indirect proportion or variation, you can say. Okay, here what is happening when we are increasing one of the value, the other value is decreasing, or when we are decreasing one of the value, the other value is increasing. Whenever you come across such situation, you can say that we are talking about indirect proportion. Okay, now let me talk about direct proportion. What is it, guys? Suppose let's say you have a fixed time. Okay, you have a fixed time. Okay, let's say 2 hours. Okay, and you have this initial point which is P. Okay, and there are two car here, car A and car B, correct? 2 hours are provided to both the cars, correct? Both the cars. Now I am talking about the distance which is traveled by both the cars in those 2 hours. So the distance that will be traveled by both the cars in 2 hours, that will depend directly upon the speed with which these two cars, that is car A and car B, are moving, yes or no. That means if the speed of car A, let's say that is more, okay, if this is more, okay, let's say the VA denotes the speed of car A, VB denotes the speed of car B. So if your VA, which denotes the speed of car A, that is more than the speed of car B, then what is going to happen? Then distance which is traveled by car A will be more than distance traveled by car B. The time is fixed for both of them. They both cannot travel for more than 2 hours. On the other hand, if the opposite happens, if the distance of if the speed of car A is lesser than the speed of car B, then the distance which is traveled by car A is going to be lesser than the distance traveled by car B. So in this situation, the second case which I have taken, what is happening? We are observing that when the speed, because time is fixed in this second case, when we are increasing the speed of any car, then the distance traveled by that particular car will also increase, or we can say the distance traveled by the car in this 2 hours of duration, that entirely depends on what the speed of car is. So this second situation which I told you just now, that illustrates what you call as direct proportion. And in both the cases, the first case which I discussed and the second case which I discussed, there was some variation or some change that was taking place, and that change was taking place because of change in some other value, and this concept is what you call as variation. Understood? So variation means when there is some change which is happening as a result of some change in some other value, that we call as variation. And there are two types of variation. We have direct variation or direct proportion, or direct variation or indirect variation. Broadly speaking, that's what we have here. Clear? All right, now check out what we have. We have direct proportion. This is an important concept. Let me mark it. Okay, this is an important point. All right. So direct proportion is the relationship between two variable whose ratio is equal to whose ratio is equal to a constant value. Okay. In other words, direct proportion is a situation where an increase in one quantity causes a corresponding increase in the other quantity, or a decrease in one quantity result in decrease in another quantity. That is absolutely correct. I told you this. I told you this, that if you have a situation or you have two variables, okay, let's say one of the variable is x y, okay, and the second variable is x. So if on increasing this variable if on increasing this variable, let's say x, your variable y also increases, okay, and if I decrease this variable x, then your variable y also decreases. I repeat, what I'm saying is, if on increasing x, your x also increases, or on decreasing x, your y also decreases. Okay, what I'm saying is, if you increase x, okay, if you increase x, then your y also increases, and if you decrease x, then your y also decreases. Then this situation leads to what you call as direct proportion. Okay, this situation leads to what you call as direct proportion. That is, if one value is increasing, the other value will increase. If one is decreasing, the other will decrease. If that happens, then such type of proportion is referred to as direct proportion. And how we denote it? If y is directly proportional to x, okay, then it is written like this: y is proportional to, directly proportional to x. This sign is the sign of proportionality. Okay, this is a sign of proportionality. This is a sign of proportionality. And always remember that whenever you remove the sign of proportionality, there is some constant which get introduced. What does that mean? That means if I remove this proportionality sign that I have, then it will be written as y is equal to kx. This k is known as proportionality constant. Okay. Proportionality constant, or you can also say constant of proportionality. Clear? Is that clear to everyone? So what is direct proportion? In direct proportion, what happens is, if one of the value is increasing, the other value also increases. While if one of the value is decreasing, the other value also decreases. That's a relation. And if, let's say, value y is directly proportional to value x, this is how we denote it: y is proportional to x. and this is the sign of proportionality. And wherever you remove the sign of proportionality, then what happens? You get y is equal to kx. Okay, where k represent proportionality constant, or you can also say constant of proportionality, like both are exactly same thing. Okay. Now, what do we have, guys? What do we have? We have one important formula, and that formula we are going to use to solve the problems. Okay, we have a formula. That formula is super important, and we will be using that formula to solve the problems. So see what that formula is. Okay, let's say we have a table. I'm drawing a table. Okay, just to illustrate you. And here we are talking about direct proportion. Okay, here I am going to denote the value of y. Here I am going to denote the value of x. So y1, corresponding to y1 you have x1 as the value of x, corresponding to y2 you have x2 as the value of x, and I am assuming here that this value y which I have, it is varying proportionality, or it is directly proportional to x. Clear? I have this y is directly proportional to x. So if that happens, we know that y is equal to kx1 is what we are going to have. Then what will happen here? You will be getting y1 is equal to kx1, correct? That means you will be getting y1 upon x1 is equal to k, right? And you will be getting y2 is equal to kx2, right? Or you will be getting y2 is equal to y2 upon x2 is equal to k, correct? So if you look at this result and this result, then from these two results, what can be said? We can say that y1 upon x1 is equal to what? That is equal to y2 upon x2, right? Or this can be written as y1 x2 is equal to x1 y2. Like that is the result which we will be using time and again to solve the problems which will be based on direct proportion. So this is very, very important. I hope you understood the meaning of direct proportion. Direct proportion means if one value is increasing, the other has to increase or must increase. If one is decreasing, the other must decrease. And this is how we denote if the two values are directly proportional. This is the symbol of proportionality. This case denotes proportionality constant or constant of proportionality. And the formula which we'll be using to solve the different type of problem is this: x1 upon y1 is equal to x2 upon y2, or you can say y1 upon x1 is equal to y2 upon x2. And this we have derived considering x and y, they are directly proportional to each other. Kindly go through it once again, note it, and ask me if you have any doubt before we actually discuss the application of this. Okay, is it done? All right, excellent. So what do we have here? We have one problem, and let's see what are we provided. An electric pole 7-meter high cast a shadow of 5 meter. Find the height of tree that cast a shadow of 10 meter under the similar condition. Okay, so I would like to know one thing from you guys here. The length of shadow that will be casted, will that depend upon the height of, let's say, pole or tree or whatever object is there under consideration, or no? The lengthier the object is, the more the length of the shadow would be, correct or not? That means if one value is more, the other value will be more. True? Means if the length of, let's say, let me consider electric pole for the reference. If the length of electric pole is more, automatically the length of the shadow which will be formed by the electric pole is going to be more. Understood? If the length of the electric pole is less, then the length of the shadow that will be formed by electric pole will automatically be less. Right or not? So this is a problem of direct proportion. Let me write here. So basically, length of shadow here that we have, length of shadow, that is directly proportional to what? That is directly proportional to length of object. Okay, that object could be tree, pole, etc. Okay, pole, tree, etc. Right? So that means this is a problem of direct proportion, right? That is, this is the case of the case of direct proportion, right? Now let us say, let us draw one table, guys. Okay, here I am writing length of, one second, let me change the size of columns. Okay, here I am writing length of object. Okay, that means pole or tree, whatever. And here I am writing length of shadow, length of shadow. Okay, so we have two cases. In first case, the length of pole is 7 meter, and when the length of pole is shadow 7 meter, the length of shadow is 5 meter. So if this is 7 meter, let us call it x1. Okay, then the length of shadow is 5 meter, and I'm going to denote it by y1. Okay, they are asking us what will be the height of tree. So let us assume height of tree would be x2, so that the length of shadow is 10 meter. So 10 meter is denoting y2. Okay. Now, as this is a problem of direct proportion, so what is the formula that we have to use? The formula that we can use is x1 upon y1 is equal to x2 upon y2, right or not? So if I substitute the value here, what will I get? I will get 7 upon 5 is equal to x2 upon 10, correct? All right, let us simplify it more. So what will you get? You will get x2 is equal to 7 into 10 upon 5. So this 5 will cancel this 10 two times. So what will you have? You will have x2 is equal to 7 into 2. And what is 7 into 2? That is 14. That means the length of the tree that we are considering, or that we are talking about here, that has to be equals to what? That must be equals to that must be equal to 14 meter for the length of the shadow to be equals to 10 meter. I hope it is clear to all of you, like how we checked whether this is a problem of direct or a direct proportion or not. We checked whether or increasing one value, the other value will increase or not. If that is going to happen, then without hesitation, you can say that that's a problem of direct proportion. Then after that, we already have the formula to do that. We applied the formula and got her answer. So check it and let me know in case of any doubt before we discuss few more problems based on it. All right, done. Excellent. So they have done it in exact same way. You can go through this solution, guys. It tells everything here. It says let the height of the tree be x meter, right? Now, this is the important point. If the height of the pole increases, the length of the shadow will also increase in the same proportion. So basically this point, which I have highlighted in yellow color, this says that this is a problem of direct proportion, because on increasing one value, the other value is also increasing. And when we will decrease one value, the other value, means if I decrease the length of the pole or the height of the pole, the length of the shadow will also decrease. So basically they exist in direct proportion. That's what they have written. And we know the formula, which is x1 upon y1 is equal to x2 upon y2, where we substituted the value, and after substituting the value and solving it, we got our answer, and that answer is 14 meter. Understood? Now we have one more problem. Check out. A train travels 200 kilometer in 5 hours. Okay. How much time, how much time it will take to cover 600 kilometer? And here we have assumed the speed of the train to be constant, means it is uniform speed. Okay. So guys, I want to ask you one thing. The distance traveled by a train and the time taken by a train, okay, if we assume the speed is constant or it is not changing, will they be in direct proportion to each other or not? That means if we increase that time, let's say, okay, let's say, because the train is traveling 200 kilometer in 5 hours, that clearly means it will, like if I increase the time, let's say I give you 10 hours, then it will travel 400 kilometers. It's very clear to us, right? Now, because when we are increasing time, the distance that is traveled by the train is also increasing. If we decrease time, that distance will travel would be less, no doubt. Okay, that means when we are increasing one value, the other value is increasing. When we are decreasing one value, the other value is decreasing. So this is a problem of direct proportion. Okay, so here, as distance traveled by train will increase will increase if time increases, if time increases, and it will decrease if time decreases. Okay, assuming speed is constant. Okay, assuming speed is constant, right? Therefore, we can say, it can be said it's a case of direct proportion. Okay, so let me draw a box. Here, let's say I am writing distance and we are going to denote the distance by x. And here I am writing time and we are going to denote time by y. Okay. So the distance travel is 200 kilometer. So that is denoting the value of x1 in 5 hours. That is denoting y1. How much this, if the distance travel is 600 kilometer, which will be x2, how much time will be taken? Let us denote it by y2. As it's a case of direct proportion, we know the formula, which is x1 over y1, that is equal to x2 over y2. Okay. So if I substitute the value, what will I get? I will get 200 over 5 is equal to 600 over y2. Okay. So what will I get? I will get y2 is equal to 5 into 600 over 200. Okay. 200 will cancel this value 3 times. So what will you get? You will get y2, that is equals to 5 into 3, that is 15 hours. That means cover to cover 600 kilometer of distance, how much time will be needed? The train will require 15 hours to cover 600 kilometer of distance. And I told you this in the beginning itself. If you are increasing the distance, or if the distance traveled is more by the train, then it's very natural the time taken to cover that particular distance would have been more. Okay, so please go through it. Ask me if you have any query before we take the next problem. All right, done. Okay, like you can see this, this is a case of direct proportion. So here t is 15 hours. They use the exact same formula, which is x1 over y1 is equals to x2 upon y2, because time taken is directly proportional to the distance covered. The more distance you are covering, or the more distance the train is covering, the time taken would naturally be more. Okay. Now we have one more problem. What does it says? It says 3 kg of sugar contains 9 into 10 raised to the power 8 crystal. Okay. 3 kg of sugar contains 9 into 10 raised to the power 8 crystals. How many sugar crystals are there in 4 kg of sugar? Okay. So it's very common thing. If you are increasing the quantity of sugar, automatically the crystals which form sugar, they are going to increase. Yes or no? If you are having 1 kg of sugar, the number of crystals will be lesser than 9 into 10 raised to the power 8. That's for sure. If you are taking 9 kg of sugar, or let's say 10 kg of sugar or more than that, then the number of crystals of sugar will increase. So basically, the total number of crystals that are there, that directly depends upon the amount of sugar that we have. Yes or no? And which says that the problem is a problem of direct proportion. So here, as number of crystals of sugar depends on, or I would say is directly proportional to, sugar is directly proportional to the amount of sugar, to the amount of sugar. So we can say it's a case of, we can say it's a case of direct proportion. It's a case of direct proportion. Okay, right? So we have to find how many sugar crystals are there in 4 kg of sugar. So one second. Here I'll be writing number of crystals in sugar. Okay. So that we are going to denote by X. And here I'll be writing amount of sugar. Amount of sugar in kg. That will be in kg. Okay. So 9 into 10 raised to the power 8 crystals are there in 3 kg. They are asking us how many crystals will be there in 4 kg. So let's say x2 crystals will be there in 4 kg. Okay. As this is a case of direct proportion, we will have x1 upon y1. That will be equal to x2 upon y2. x1 is 9 into 10 raised to the power 8. Y1 is 3. X2 is, like, we don't know what x2 is. Y2 is 4. So if you simplify it more, you will get x2 is equal to 4 into 9 into 10 raised to the power 8 divided by 3. This 3 will cancel this 9 3 times. So you will be getting x2 is equal to 12 into 10 raised to the power 8 crystals. You can either leave it right like this, or you can say you will have 1.2 into 10 raised to the power 9 crystals. Both are exactly same thing. So because your amount of sugar increased, okay, earlier we were talking about 3 kg of sugar, and now we are talking about 4 kg of sugar. So because amount of sugar has increased, so it's very natural the total number of crystals that we have in the sugar, that is also going to increase. So like that's what we have to do in this problem. Please go through it. Ask me if you have any query. All right, clear? Okay. You can check here what how they have done. let the required number of crystals be x. Okay, and in 3 kg there are 9 into 10 raised to the power 8 crystals. In 4 kg they assume the crystals to be x. So since the two quantities are directly proportional to each other, the reason is very clear. If you increase the quantity of sugar, the number of crystals that are present will automatically increase. So because they are directly proportional, so we know the formula, that is x1 over y1 is equal to x2 over y2. They substituted the value, solved it, and thereafter they got x is equal to 12 into 10 raised to the power 8, or 1.2 into 10 raised to the power 9 crystals, which is same as what we got earlier. Okay, so it's only about extracting what is given, and if you are able to do that, problem is not tough. बहुत आसान होती है. ठीक है. So these two problems you guys have to do as a homework. Problem one, the scale of a map is given as this. Okay, two cities are this apart. All right, that you have to decode, guys. What is given? If the cost of 20 books is rupees 180, how much will 15 books cost? That's very natural. If you are increasing the number of books that you are going to purchase on a shop, the total money that you have to pay for that books will also increase. Means the cost or the amount which you have to pay for purchasing the books, that entirely depends on how many books you are purchasing. More books, more money you have to pay. Lesser books, less number of books, less money you have to pay. And that reflects, or that directs us that this is a problem of direct proportion. Understood? So what all we covered in this session? In this session, first we started with the weightage of this particular chapter in your board, in your school examination and in your Olympiad examination. Then we studied what variation is and how this topic is related to our real life. We took few examples. After that, we studied what is a direct proportion actually, and like how to see or how to know whether the given problem is a case of direct proportion or not. I told you, if one value is increasing, and on increasing of that particular value, if the other also increases, it's a problem of direct proportion, right? The opposite is also true. That means if one is decreasing, the other also decreases, then also it's a problem of direct proportion. But if one is increasing, the other is decreasing, and vice versa, then it is not a problem of direct proportion. That will be a problem of indirect proportion. Okay, that's how you can check it. Then I told you, if any one variable is directly proportional to another variable, how we represent it. What is the symbol we have for proportionality? What is proportionality constant? And if there are two quantities which are varying directly with each other, right? If there are two values or two quantities that are varying directly with each other, what is the formula that we have? And that formula helped us a lot to do all these problems. So I hope all that is very clear to you. In case you still have any doubt, please feel free to get in touch with your Ask Guidance expert, and he will certainly help you out with that. So that's it from this session. Thank you so much for attending. Have a great day.